Hello, welcome back. Today, let's try to solve another Leetcode problem. 1289, minimum folding parts, sum 2. So this means if we are given a matrix, so this is a grid, so we're gonna calculate the folding parts sum. So for example, this is a 1, but for the next row, it cannot be the same column. It must be at another column, for example, 5 and 6. But what we're going to choose? We're going to choose 5. What about the next row? We're going to choose 7. So the final result is 13. Yeah. So as you can see, this is typically a dynamic programming problem. Yeah. So in Leetcode, it is tagged hard, but actually it should be like a easy and medium problem. Now let me go to the whiteboard to explain it, and then go to the code editor to finish the coding. As you can see, this is from the example 1, 2, 3. So for our dynamic programming, we're gonna define a DP array. So this is our DP array. For the first row, it will be 1, 2, and 3, and then we're gonna calculate the second row. So for the second row, for this position, because we cannot choose 1, but we can choose 2 and 3. So what is the minimum? So 4 plus 2, it is the minimum. So this is 6, and let's try the next position. So what about this position in the middle? Yeah, because in the middle it is 5. We cannot choose 2, but we can choose 1 and 3. What is the minimum? So the minimum is 6. Now let's go to the next. Yeah, so for this position we cannot choose 3, but we can choose 1 and 2. But the minimum is 1. 1 plus 6, it is 7. So here it's gonna be 7. Now let's go to the next row. So for this row we cannot choose this 6, but we can choose this 6 and 7. So 6 plus 7, it is 13. 13 is the minimum. And then we go to the next. We cannot choose this 6, but we can choose this 6 and this 7. So 8 plus 6, it is 14. So 14 is the minimum. And then let's go to the last position. And for this position, we cannot choose 7, but we can choose 6 and 6. So the 6 plus 9, it should be 15. So the 15 should be the result. Yeah, but our final result should be minimum of the last row. So it is 13. So this is our final result. Now let's go to the code editor to finish the coding. Actually, this coding is much simpler, than you think. Yeah, basically we're gonna define row and column. So the row would be the length of the grid, and the column would be the length of the grid 0. So this is my template for defining the row and column, because in different IDE in different coding platforms have the different representations. Yeah, but here I always use R represent row and C represent column. Yeah. And then I'm going to define my DP array. So for the DP array, it will be 0 times the column, and for R in range R. So this is my definition of the DP array. So for the first row, I'm going to have the same numbers as here, 1, 2, and 3. So what am I going to do? I just need a for loop. Yeah. So for I in, let's make it C. So for C in raised columns, DP 0 C. 0 means the 0 row, and C means at each column of the 0 row. So the DP 0 C should be equal to grid 0 C. Yeah, let's check if it is right. Let's just print out the DP, and I just gonna return a 0. Here is not the right answer yet. We just need to check the DP array if we already have the first row's value or not. Yeah. Now let's check it. We have 1, 2, and 3. It seems we are right. Yeah. So we just need to have this 1, 2, and 3. Now let's continue. We just need to loop through the row and column. So for R in range, because the first row has already been defined in our DP array, we just need to go to the second row, and then we go to the columns for C in range C. and then we're gonna get our result. So for dp_rc should equal to grade rc plus the minimum of the previous row. For example, if we are going to calculate the second row, we just need to calculate the previous row. So here should be dp r minus 1 with c, because this number, the same column should not be included. So this is why here I'm going to use a c plus another subarray. It is the dp r minus 1 and c plus 1. Why we use this kind of a method? Because in Python it is much easier, because we can directly use the array to plus. So this means the previous row, this is the current position of the current row, for example this place, but we cannot use this place yet. We have to use this one and this one. So this is why we use dpr minus 1. Here is also dpr minus 1 and plus some value to this column, and here the next column c plus 1 to the next. So here this c column is not included because we use this kind of representation. So basically the dp array has already been finished. Now let's just print the dp array to see what is inside. Let's check what is inside the dp array. Is it as expected? As you can see, now our dp array is 13, 14, and 15 for the last row. So this is before the initialization. It is 1, 2, 3, always be 0. And this is when we finished our calculation. It is 13, 14, and 15. So what are we going to return? We're just going to return the minimum of dp minus 1, because dp minus 1 is the last row. The minimum is 13. Now we just need to delete the print and check if our function is right. Now let me run it to check if there are any mistakes. No, let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this.